Hello, and welcome to this video on convergence of a series. We're going to show that the series sum from 1 to infinity of a times r to the n minus 1 converges to a divided by 1 minus r as long as the absolute value of r is less than 1. So let's suppose that the absolute value of r is less than 1, and let's show that the series that we have here converges to a over 1 minus r. To show that we have that convergence, we need to show that the sequence of partial sums Sn converges to the value we see on the right-hand side of the equation, a over 1 minus r. By definition, the series converges if the corresponding sequence of partial sums converges, and in the case the sequence of partial sums converges to a limit, that limit is the same as the limit of the series. So we need to show that the sequence of partial sums converges to a over 1 minus r to show that this series is equal to a over 1 minus r, in the case r is less than 1 in absolute value. Now to show that this partial sums converge to a over 1 minus r, we're going to find an explicit form of S sub n. So notice that S sub 1 is the addition of the first term of the series, so that's just a. S sub 2 is a, the first term, plus the second term, a times r. The third sum is a plus ar plus ar squared, and so on. We can find a more explicit version of S sub 3 by doing S sub 3 take away r S sub 3. Let's see how that goes. And from that expression, we will get to see how to find an expression for S sub n. If we do S sub 3 minus r S sub 3, then we're doing a plus ar plus ar squared, take away ar plus ar squared plus ar cubed. We multiply each term in S3 by the constant r. And then we get a few cancellations. ar minus ar is 0, ar squared minus ar squared is 0, and we end up with a minus ar cubed. And that's the same as 1 minus r times S3 on the left-hand side, because S3 is a common factor. So S3 is a times, well, just a minus a times r cubed divided by 1 minus r. We can rewrite that as a multiplied by 1 minus r cubed over 1 minus r. Let's see what we do with Sn in general. When we have Sn, we're adding terms from a to a times r to the n minus 1. Then when we take Sn and subtract r times Sn, we're taking all those terms from a to a times rn minus 1 and subtracting, if there's a little bit to the left, subtracting terms that look like ar plus AR squared all the way to AR to the n minus 1 and then AR to the n. And we get a lot of cancellations in the middle, like AR minus AR is 0, AR to the n minus 1 is gone. And with this one, that's going to go away with this term that will be here in the middle, and so on. So all the middle terms are gone, and we get A minus A times R to the n. So 1 minus R times Sn is equal to A minus A times R to the n. That means that Sn is A minus A times R to the n divided by 1 minus R. Or same thing, A times 1 minus R to the n divided by 1 minus R. Okay. So then what we have here is that the partial sum, the nth partial sum of the series, that is the geometric series we have right here on the left, is A times 1 minus R to the n divided by 1 minus R. Since that happens, we have A times 1 minus R to the n over 1 minus R. And the limit of R to the n is 0 because R is less than 1 in absolute value. We have that the limit of Sn as n goes to infinity is a number we can find because we do 1 minus the limit of R to the n and then divided by 1 minus R. So we obtain A times 1 minus 0 divided by 1 minus R, and that's A divided by 1 minus R. This shows that the sequence of partial sums converges to A over 1 minus R. That means, by definition, that the series sum from 1 to infinity of A times R to the n minus 1 is equal to A over 1 minus R. Right? That's it for this example. If you have any questions, make a comment and I'll be doing my best to respond to those questions. All right, thank you for watching. Bye-bye.